Hello Year 12 Further Mathematicians. I'm going to attempt a question which was requested from today's exercise, which was the extra content to do with parametric equations. Now, you might already see on the back of this, I've already attempted this question once and got it wrong, which wasn't ideal. So this is my second attempt, and hopefully this will go a little bit better than the previous one. So, we have a parametric equation, this closed curve, actually this continuous curve which looks like a fish, and then we've got a straight line called L passing through point P, and we have to find the area which I've shaded and labelled R. Now, even if this wasn't parametric equations or whatever, the method or the initial first step is exactly the same no matter what. For that type of area, because integration gives you the area trapped between the x-axis and vertical lines, the only sensible bit of area we could work out is the entire thing. So we could use integration to work out the area of the entire thing, and then we'd have to subtract that triangular object there. So in other words, area of R is equal to area under curve subtract area of the triangle. Okay, so we have to do these separately. So let's try and do the area under the curve. Now, the first thing I want to do is if this was just normal integration, I would know what the x coordinates are there and there, and I'd integrate between those x coordinates. And I'm kind of going to start off doing exactly the same. So for this point on the curve, the x coordinate is clearly 0. And at the moment, the y coordinate is unknown. Okay. But let's try and work it out, for example. So if I said x is equal to 0, how could I work out the y coordinate? Well, the thing that connects x and y in a parametric equation is the parameter t. So I kind of need to work out the parameter t and then work out the corresponding y coordinate. So 1 minus t squared is equal to 0. And when you solve that, you get t is equal to plus or minus 1. Now, can't really have two answers, but they say t can be any real number, so I can't discount either. So let's just see what the y values would actually be. So y would be equal to 2. Let's try plus 1 first. 2 plus 1 minus plus 1 cubed, which would give you 1. And the second y value would be 2 minus 1 subtract minus 1 cubed, which is equal to minus 1. So based on that point there, the y value which makes sense is the one which is plus 1. So that is 1, and that came from t was equal to plus 1. So let's keep track of that. T is equal to plus 1. I've just written there. Okay. This point there, which I'll call Q. Again, I want to know what the x value is, but the only thing I've been given is the y value, which is 0. So something 0. Let's work out the corresponding x value. 2t subtract t cubed is equal to 0 from the equation above, to give you factorise t brackets 2 minus t squared is equal to 0. Remember, this is a cubic and you expect 3 answers. You can actually cheat here and use the difference between two squares. This is t brackets root 2 minus t root 2 plus t is equal to 0. And end up with 3 answers: 0, root 2 or minus root 2. But again, I don't know which one of those answers is correct, because that would be giving me every single point where the y value is 0, and in that curve above that appears more than once. So let's see which one's the correct one. So let's look at the x values. So x equals 1 minus 0 squared, which is 1. That looks promising. That x coordinate needs to be a positive number, so that's probably right. Just show you what the others would give you. X equals 1 subtract root 2 squared. That would give you negative 1, which is probably this point over there. And x equals 1 minus negative root 2 squared gives you negative 1 as well, which again is the wrong point. It's the one on the left. So those didn't count. Also that one over there didn't count, which means the x coordinate is 1. And what was the value of t which produced that? That was t was 0. So all I've done so far is kind of identify the important points in the curve, which are the x values there and there. But I've worked out more information than I would normally do, which is the corresponding y values and also the corresponding parameter as well, which would work, because that might be useful when answering this question. So, area under the curve, back to what we would like to do. So, area under curve. For a parametric equation, the formula is integrate between the upper limit and the lower limit of y dx dx by dt dt, and for our curve y would be, given in the question, is 2t subtract t cubed, and dx by dt, if you look at that, the dx by dt that would be negative 2t. So area under the curve is negative 2t there, sorry, and that's integrating with respect to t. This is the important part now. From the curve, if I was doing this using a Cartesian equation, my lower limit would be this point, my upper limit would be this point. Lower, upper, which means that's my lower limit and that is my upper limit. Even though that's plus 1 and 0, that is the lower limit, that is the upper limit. Okay, the pattern doesn't change. So 1 and 0, upper and lower. It seems to be the same workings as my previous attempt, which suggests my mistake was later on in the question, or I'm making the same mistake twice, which isn't ideal. So I would expand the brackets, and I feel like that is correct with respect to t. That's a t squared. Maybe that was my mistake from earlier. I think it was. Almost made the same mistake twice. I'm going to check. Yeah, I forgot the t squared earlier. Never expand brackets. Should have known better. Okay, let's add 1 to the power. Divide by the new power. Add 1 to the power. Divide by the new power and substitute in the limits. Upper limit goes in first. Lower limit goes in second. If you type that into your calculator, 0 subtract that bracket, try again, there we go. 14 over 15. Well, that's different to what I got earlier, which is good news. Right, so I've got the area under the curve, which you might think that is the difficult bit. You might be wrong. Okay, so next thing I need to work out is the area of the triangle. Now, normally the area of a triangle like that shape, so this triangle there, would be base times height divided by 2, or half base times height. Now, good news is I know what the height of this triangle is. I kind of worked it out there. It's a height of 1. But I haven't worked out the base, and there's one thing mentioned in the question which I haven't even used at all yet, which is the fact that this straight line is normal to the curve at point P, which means if I knew the gradient of the tangent, it would be perpendicular to it. Now, the good news is if I did work out the equation of this line, then I could work out the x-intercept, which would therefore be the base of this triangle. So I need to work out the equation of a straight line, and normally that is really straightforward. Let's see if that's the case in this one. So, equation of L. I'm going to state 3 things. The first of those 3 things is a point on the line. Now, a point on the line was 0, 1, if you look at it, point P. Gradient of the line. Because this attached to a curve, I need to use dy by dx. But how do you work out dy by dx for parametric equations? You do dy by dt over dx by dt. I haven't worked out dy by dt yet. So substitute both of those in. Okay, now that gives you the gradient of the tangent at any parameter t. What parameter did we want for this point? Remember, Q has nothing to do with a straight line. P has everything to do with a straight line, and that was parameter t is equal to +1. So we substitute +1 into this. Gradient of tangent. If you put +1 into this, what are you going to get? You're going to get a half, which means the gradient of the normal, which is perpendicular, would be -2. And the third and final thing is the formula. And in this case, believe it or not, I'm not going to use y minus y1 equals m brackets x minus x1, because I've been given the y-intercept straight away. I'm going to skip to y is equal to mx plus c. I have y is equal to -2x plus 1. And that would be the formula for the straight line L. And remember, the reason I worked that out was to work at the base of that triangle, which is another thing called the x-intercept in this case. The x-intercept happens when y is 0. And if you solve this equation to get x equals by itself, you get x is a half. So the base of that triangle back at the start is a half. Right, area of triangle. Base times height divided by 2, or half, times the base, which is a half, times the height, which is 1, which is a quarter. And then my final answer is going back all the way to this line, which is the area R is equal to the area under the curve, which I worked out at some point to be 14 over 15. Subtract a quarter. And if you type that into your calculator, hopefully it will match up with the answer given on the image in the book, 41 out of 60, which is perfect. Slightly annoyed that I didn't get this the first time around based purely on expanding brackets wrong, but there we are. Okay, any questions about that, let me know.